Good morning, Grade 7. Today's discussion will be about Quarter 3, Module 5, Characteristics of Light. Objectives: explain color and intensity of light in terms of its wave characteristics. At the end of this module, you should be able to 1. Describe light. 2. Explain the color and intensity of light in terms of its wave characteristics. 3. Calculate the speed of colors based on their frequency and wavelength. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 6 to 7 of Quarter 3, Module 5. What's in? Fill in the letters in the boxes below to form the missing word. 4 related pictures are shown in each item to serve as clues. What's new? What do you know about light? Fill in the graphic organizer below. Characteristics of light. How important is sight to you? Will you be able to do your everyday activities without the gift of sight? Visible light makes you see things around you. But how does light behave so that you can see? Sir Isaac Newton believed that light behaves like a particle. He proposed the corpuscular theory. According to Newton, a source of light emits many minute, elastic, rigid, and massless particles called corpuscles. These particles travel through a transparent medium at very high speed in all directions along a straight line. So according to Newton, light is made up of a stream particles and shadow formation is an evidence of this. Next, Christian Huygens believed that light behaves like a wave, so he proposed the wave theory of light. This was further investigated and supported by other scientists, resulting in the two most obvious patterns of light in terms of the wave theory. The first one is intensity or brightness, and the second one is color. The science of measuring the intensity or brightness of light is called photometry. Light may come from natural or artificial sources. So let's take a look at the following. So for natural sources, we have first the sun, number 2, stars. For artificial sources, we have a light bulb, a torch or a flashlight, and a candle. Luminous objects such as the sun and the stars give off their own light. So pag sinabi po nating luminous, it means that these objects have their own light. The brightness of light that these objects produce is known as luminous intensity. This is measured in terms of candela. The symbol for candela is a small letter C and a small letter D. So for example, we have a light source, the sun. So the brightness of light that the sun produces is known as luminous intensity. So when the sun shines on objects, so the brightness of light that the sun produces is called as luminous intensity. On the other hand, non-luminous objects like the moon reflect light from other sources. The amount of illumination they receive is called illuminance. So, ang moon, they don't have their own light. So, they only reflect light from other sources such as the sun. So, yung amount of illumination that they receive from the sun is called as illuminance. Illumination is determined as follows. E equals I divided by R squared, where E stands for illuminance, which is measured in lumen, symbol, small letter L, small letter M. I is for intensity, measured in lumen per square of distance, or small letter L, small letter M, slash M squared, or lux. R stands for distance of source, which is measured in meters. Symbol, small letter m. The illuminance on a surface perpendicular to the luminous flux is directly proportional to the luminous intensity of the source and inversely proportional to the square of the distance from the luminous source. So ano ibig sabihin ng binasa natin ito? E is equal to I divided by R squared. So in the previous slide, nagpakita tayo ng formula in solving for illumination, where E is illuminance, I is intensity, and R is the distance of the source. So ano ibig sabihin ng statement na to? So we have these two statements. So first one, greater intensity of the source means greater illuminance. Kapag ang ating light source ay mataas ang kanyang light intensity or mataas ang kanyang energy, mas maliwanag. Okay, greater ang illuminance. Next, number 2, greater distance between the luminous source and the reference object means lesser illuminance. Mas malayo ang distance or ang pagitan ng ating light source sa ating reference object, mas lesser ang illuminance or mas mahina ang liwanag. So to further explain those statements, let's take a look at this. So the distance of the source to the surface of the object affects the amount of illumination or illuminance. So nakakaapekto daw ang layo ng light source natin doon sa ating reference object. So which of the two plane boards receive greater amount of illumination? So to answer this question, let us study the diagram. So in letter A, we have a plain whiteboard located 0.5 meters away from a candle producing an intensity of 10 lux. So sa letter A po, meron tayong light source which is the candle. Ang pinoproduce niya na intensity ay 10 lux. Tapos, ang layo ng candle mula dito sa ating plain whiteboard ay 0.5 meters. Next, let's go to letter B. In letter B, a plain whiteboard is located 1.0 meter away from a candle producing an intensity of 10 lux. So sa letter B naman po, ang ating light source is again a candle at same lang ang kanyang intensity, 10 lux. But this time, ang distance ng candle from the plain whiteboard is 1.0 meters. So which do you think, okay, receive a greater amount of illumination? Is it letter A? Is it letter A or letter B? So, ang sagot dito, syempre, ay ang letter A. So, dito sa letter A, mas greater ang illumination na na-receive ng plain whiteboard in letter A because yung distance ng ating source to the surface of the object is nearer, mas malapit, 0.5 meters lang. Unlike dito sa letter B, ang distance ng ating light source from the surface of the plain whiteboard is 1.0 meter. Kaya, mas greater ang illumination or mas greater ang illuminance dito sa letter A. The plain whiteboard in figure A received greater illuminance compared to the plain whiteboard in figure B. The distance of the source to the surface of the plain whiteboard affects the amount of illumination received or illuminance. In other words, the intensity of illumination decreases when the distance between the source increases. So habang lumalayo daw yung pagitan ng light source at yung surface ng ating object, ang intensity of illumination ay bumababa. So, mas malinaw or mas malakas ang illuminance dito sa letter A kumpara sa letter B. Remember, the illuminance on a surface perpendicular to the luminous flux is inversely proportional to the square of the distance from the luminous source when the intensity of the source remains constant. So, if the distance becomes greater or higher, illuminance decreases. So, yun ang ibig sabihin ng salitang inversely proportional. Kapag yung isang quantity Halimbawa, yung distance ay tumataas or nag-i-increase, yun namang illuminance natin ay bumababa. So, illuminance is inversely proportional to the square of the distance from the luminous source when the intensity of the light source remains constant. So, that would explain kung bakit ang plain whiteboard sa letter A ang naka-receive ng greater illuminance as compared with plain whiteboard letter B. The intensity of the light source affects the amount of illumination received. Which of the two plain boards receive greater amount of illumination? So to answer this question, let's take a look at our figures. So in letter A, we have a plain whiteboard located 1 meter away from a candle producing an intensity of 10 lux. So, dito sa figure letter A, our light source is a candle. Tapos, ang kanyang light intensity, 10 lux. The candle is located 1.0 meters away from a plain whiteboard. Next, in figure B, we have a plain whiteboard located 1.0 meter away from a light bulb, producing an intensity of 1,000 lux. So, in figure letter B, our light source is a light bulb, and the intensity it produces is 1,000 lux. Now, our light bulb is located 1.0 meters away from our plain whiteboard. So, dito sa figure A and B, ang distance ng ating light source from the plain whiteboard ay parehong 1.0 meters. Ang pinagkaiba nila this time ay yung intensity ng kanilang light source. So, sa letter A, 10 lux yung candle. Tapos sa letter B, yung ating light bulb ay 1,000 lux. So, let's answer. Which of the two plain boards receive greater amount of illumination? So, based from our drawing, we could clearly see na ang greater amount of illumination is received by plain whiteboard letter B. So, bakit? So, very simple. Ang intensity ng light source affects the amount of illumination. Mas mataas ang intensity ng light bulb kaysa sa intensity ng candle, which is only 10 lux. So the plain whiteboard in figure B received greater illuminance compared to plain whiteboard in figure A. So the intensity of the light source affects the amount of illumination received by the plain whiteboard. In other words, the intensity of illumination increases when the intensity of the light source increases. Kapag ang intensity ng light source ay mataas, mataas din po ang ating illuminance. So remember, the illuminance on a surface perpendicular to the luminous flux is directly proportional to the intensity of the source when the square of the distance from the luminous source remains constant. So ano ibig sabihin nito? Kapag ang intensity ng ating light source ay mataas, mataas din po ang ating illuminance. So, yun ang ibig sabihin ng salitang directly proportional. So, dito sa ating drawing, the plain whiteboard in figure letter B received a greater amount of illuminance because the light bulb's intensity is 1,000 lux as compared to the intensity of the candle, which is only 10 lux. Lesson 2. The color of light. The color of light depends on the frequency or wavelength of the radiation that reaches the eye. Visible light, which travels at a speed of 3 times 10 to the positive 8 meters per second, falls in the wavelength range of about 400 nanometers to 750 nanometers. The range is known as the visible light spectrum, and within it lies the different colors from violet to red as shown in figure number 1. So here we have figure number 1. This is the electromagnetic spectrum, and within it are the different examples of electromagnetic waves, starting with radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So visible light, this portion here, Okay, visible light is the portion of the electromagnetic spectrum that is visible to the human eye. Electromagnetic radiation in this range of wavelength is called visible light or simply light. A typical human eye will respond to wavelengths from about 400 to 750 nanometers. So, ang electromagnetic wave na pwede lang makita ng ating mata ay ang visible light. So, within the visible light lies the different colors from violet to red. So, ang iba't ibang colors in the visible light spectrum are red, orange, yellow, green, blue, and violet. If the light has a wavelength shorter than 400 nanometers, it is called ultraviolet light UV. But if it has a wavelength greater than 750 nanometers, it is called infrared light or IR. A shorter wavelength means a higher frequency, whereas a longer wavelength has a lower frequency as shown in figure number 1. So, ano ibig sabihin nun? Kapag ang wavelength ay mababa, ang ating frequency, pati ang energy ay mataas. Kapag ang wavelength naman ang mataas, ang frequency at energy naman po ang mababa. So, wavelength is inversely proportional to frequency as well as energy. Kapag ang wavelength ay mababa, ang frequency at energy mataas. Kapag ang wavelength ay mataas, ang frequency and energy ay mababa. So, if you would look at this, so sa ating electromagnetic spectrum, the electromagnetic waves with the longest wavelength ay radio waves. So, dahil pinakamataas ang wavelength ng radio waves, ang kanyang frequency at ang kanyang energy mababa. Tapos, si gamma rays naman ang merong shortest wavelength, dahil pinakamaigsi yung wavelength niya, yung kanyang frequency at energy naman ay mataas. Okay? So, from gamma rays going to radio waves, the wavelength is increasing. From radio waves going to gamma rays, the frequency is increasing. From radio waves going to gamma rays, the energy is increasing. So, sa visible light, balik tayo dito sa visible light, parehas lang din. So, red has the longest wavelength, violet has the shortest wavelength. Okay? Tapos, ang red natin na merong longest wavelength, siya naman ang merong lowest frequency and lowest energy. Tapos, si violet na merong shortest wavelength, ang merong highest frequency and highest energy. As you could see sa mga labels na nasa taas. So, si red ay 700 times 10 to the negative 9 meters ang kanyang wavelength. Si violet naman, 400 times 10 to the negative 9 meters. So, red, longest wavelength, violet, shortest wavelength. Sa frequency naman, si red, 422 times 10 to the positive 12 per second ang kanyang frequency. So, lowest frequency. Si violet naman, 740 times 10 to the positive 12 per second ang kanyang frequency. So, highest ang frequency ng violet. When light passes through the prism through a phenomenon called dispersion, the light spreads out into bands of colors called spectrum. A prism separates white light into the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet, or Roy G. Biv. So let's take a look at this picture. Dispersion of light. So the dispersion of light is the phenomenon of splitting of a beam of white light into its 7 constituent colors when passed through a transparent medium. So this transparent medium is called a prism. A prism is a transparent optical element with flat, polished surfaces that refract light. So when white light enters a prism, the white light is refracted, nabebend siya, and the constituent colors of white light is separated. So, nagkakaroon tayo ng colors na red, orange, yellow, green, blue, indigo, and violet. So, dispersion of light happens not only when you put a beam of white light through a prism, but also it happens in nature. The spectrum is due to the difference in the indices of refraction or differences in velocities and wavelengths of spectral colors. So in our visible light spectrum, we observe different colors because of the difference in the indices of refraction. And for each spectral color, Roy G. Vib, different din ang velocities and wavelengths. So this happens because the index of refraction of a material depends on the wavelength. So the index of refraction is the ratio of the speed of light in a vacuum to the speed of light in a given material. So N equals C divided by B, where C, or the speed of light, is equal to 3 times 10 to the positive 8 meters per second. The higher the index of refraction, the more it bends the light. Thus, violet light bends more than red light. This is clearly evident if you observe a rainbow. So rainbow is one example of dispersion of white light. So usually, we observe rainbows after it rains. So after it rains and then the sun shines, the white light from the sun passes through raindrops in the air. So the raindrops in the air serves as prism, and white light is separated into its constituent colors. Roy G. Bibb. So we have red, orange, yellow, green, blue, indigo, and violet. So here, we can see or we can observe that violet light is more bent than the colors above it because of the higher index of refraction. Let us answer the different activities in what's more, starting with independent activity 1. So make your own prism by shining light down through a glass of water on white paper below, or shine a light on the back of a CD. Be patient and experiment until you get the angle just right. Draw in the box what you observe below and answer the guide questions. So number 1, what did you observe? 2, what colors were reflected? Enumerate. So, gagawa daw kayo ng prism. So, kuha ng glass of water, get a flashlight, tapos shine your flashlight through the glass of water. Tapos, be ready, dapat merong white paper na sasalubong doon sa light from the flashlight. So, what did you observe? Pwede kayong mag-take ng photo para makita kung ano yung naobserbahan ninyo. What colors were reflected? So, i-enumerate nyo dito. Next, independent assessment 1. Read each of the following statements carefully. Write fact if the statement is correct and bluff if the statement is wrong. So write your answer on the blanks before the numbers. Number 1, light travels in straight lines. 2, light travels faster than sound. 3, scissors are shiny because they absorb light. 4, to make a wall reflect as much light as much as possible, you should paint it white. 5. When light is absorbed by a surface, it doesn't bounce back. 6. Dark-colored and smooth surfaces reflect light well. 7. The human eye needs light to see. 8. The color we see is a result of which wavelengths are reflected back to our eyes. 9. Dispersion is a phenomenon in which prism separates white light into its component colors. And 10. All colors of light have equal speeds in a vacuum. Next, independent activity 2. Use the figure of visible light spectrum to complete the table below. Answer the guide questions that follow. So we have visible light spectrum, red, orange, yellow, green, blue, and violet. So wavelength in meters, frequency in per second. So red, 700 times 10 to the negative 9 meters. Violet is 400 times 10 to the negative 9 meters. Red is 422 times 10 to the positive 12 per second, and violet is 740 times 10 to the positive 12 per second. So you are going to complete this table using the data that we have here above. So first column, color spectrum. So write the colors, red, orange, yellow, green, blue, and violet. Tapos, susulat nyo din dito yung frequency. So for red, it's 422. So saan nanggaling yung 422? Ito po. Okay, tapos susulat nyo rin yung frequency ng orange, yellow, green, blue, and violet. Next column, we have wavelength. So, yung wavelength ng red ay 700. So, saan ang galing yun? Dito po. So, kukunin nyo yung wavelength ng red, orange, yellow, green, blue, and violet. And then, for the last column, frequency times wavelength. So, you are going to multiply the frequency and wavelength for each color spectrum para masagutan ninyo yung ating speed, wave speed. So, for red, for 122 times 10 to the positive 12 per second times 700 times 10 to the negative 9 meters, ang sagot ay 295,400 times 10 to the positive 3 meters per second. Or, pag ni-round off siya, is equal to 3 times 10 to the positive 8 meters per second. So, pag na-compute nyo na lahat, pakilagay po dito ang sagot. Next, independent activity 2. So, guide questions. Which color registers the highest frequency? So, doon sa colors na nakalista sa ating visible light spectrum, red, orange, yellow, green, blue, and violet, alin doon ang merong highest frequency? Next, shortest wavelength. Number 2, which color register the lowest frequency? Alin naman daw yung may lowest frequency and longest wavelength? Number 3, what do you observe with the wavelength and frequency of the different colors? So, ano daw ang relationship ng wavelength and frequency? So, kanina, sa mga previous slide, in-explain natin to, kapag ang wavelength ay mataas, ano nangyayari sa frequency? At kung ang wavelength ay mababa, ano nangyayari sa frequency? So, are they directly proportional or inversely proportional? Next, number 4. What did you observe in the product of wavelength and frequency for each color? What is the significance of this value? So, nung minultiply nyo yung wavelength at frequency ng bawat color spectrum, meron daw ba kayong napansin doon sa naging sagot ninyo? So, ano daw ang significance ng value na nakuha ninyo? Okay, yung pinakasagot. Anong ibig sabihin nun? Next, number 5. What can you say about the speed of the different colors of light in air? Okay. Next, independent assessment 2. Fill in the boxes with parts of the electromagnetic spectrum. So, dito sa mga boxes na to, ilalagay po ninyo kung anong mga electromagnetic waves ang dapat nandyan. So, halimbawa, dito sa first box natin, so siya yung may pinaka-longest wavelength. Okay? So, kung ano yung may pinaka-longest wavelength, lagay nyo dito. Tapos, kung ano naman yung pinaka-shortest ang wavelength, sulat nyo din dito. Tapos, in between the wave with the longest wavelength and the shortest wavelength, so susulat nyo rin siya dito. Next. Independent assessment 2. Draw a line to match each item on the left with the kind of wave it produces from the choices on the right. So, example, mobile phones, sunbed, radiotherapy, TV transmission, thermal imaging. So, what kind of waves do these technologies produce? So, you are going to choose dito sa ating second column, radio waves, microwaves, infrared, gamma rays, and ultraviolet. Next, what's more, independent activity 3, study the illustration and answer the following guide questions. So, number 1, which of the two boards receive greater illuminance? Why? So, dito daw sa dalawang boards, alin ang merong greater illuminance? Is it A or letter B? Which between the two boards receive lesser illuminance? Why? 3. How does the distance of the source affect the amount of illumination received by the board? And 4. How does the intensity of the source affect the amount of illumination received by the board? So, sa number 3, ano daw ang epekto ng distance ng light source, okay, sa amount of illumination received by the board? So, kapag mas malayo ang light source sa reference object natin, what happens to illumination? Tapos sa number 4, yung intensity or yung lakas ng isang light source. Paano daw niya naaapektuhan yung amount of illumination received by the board? Okay? So, independent assessment 3 solve the following problems. Barangay Poblacion experienced a rotational brownout. Pepay decided to use a candle to read and review her keynotes as preparation for their examination. She pinned her notes to the surface of the wall and placed a candle 0.6 meters away from the wall. Calculate the illuminance received by the notes if the intensity of the candle is 12 lumen per meter square. So to solve for this problem, let us first identify the given, 0.6 meters and 12 lumen per meter squared. So, yung given natin ay 0.6 meters and that is the distance of the source. 12 lumen per meter square is your intensity. Ang nawawala natin ay illuminance, unknown. So to solve for illuminance, let us use the formula E equals I divided by R squared. So substitute lang natin. The intensity is 12 lumen per meter squared. The distance of the source is 0.6 meter. Okay, so i-square yun. So 0.6 squared is 0.36. So magiging ng meter squared yung ating unit. So 12 divided by 0.36 is equals to 33.33. So, ang meter squared ay makakancel. Cancel. So, ang matitira na lang natin na unit ay lumen. So, ang ating magiging final answer ay 33.33 lumen. So, yung candle natin ay merong illuminance na 33.33 lumen. So, for number 2, okay, on the first day of November every year, Filipinos make their way to cemeteries and churches to pay their respects to loved ones who have died. During Undas, cemeteries are often packed with people giving flowers, candles, and food to remember the dead. Calculate the illuminance received by a gravestone located 0.25 meters in front of a candle, producing 10 lumen per meter squared. So, ang given ay distance of source, 0.25 meters, intensity ng candle, 10 lumen per meter squared, solve for illuminance. So, para ma-solve nyo to, use the formula illuminance equals intensity divided by distance of source squared. Okay? So, substitute lang, 10 lumen per meter squared divided by 0.25 meter squared. Okay? So, kayo na mag-solve. Number 3, Mrs. De la Cruz is a history teacher. She decided to play a video that shows the heroic life of local heroes of the province of Bulacan. She used LCD projector to play the video. The LCD projector is located at a table 2 meters away from the white screen. Calculate the illuminance received by the white screen if the LCD projector produces 850 lux. So to solve for this, let us write the given. R equals 2 meters. Intensity is 850 lux. Illuminance is unknown. So to solve for illuminance, use the formula E equals I divided by R squared. So sa substitute lang natin, 850 lux is equal to 850 lumen per meter squared. So bakit? Kasi sabi dun sa ating hint, 1 lux is equals to 1 lumen per meter squared. Okay? So, kaya ang nilagay ko na dito, 850 lumen per meter squared. And then, 2 divided by 2 meter tas squared. Okay? So, pakisagutan na lang to. Next, what I have learned, complete the concept map below. So, going back to the previous slide, we have discussed about the electromagnetic spectrum and the visible light spectrum. So, ilalagay nyo dito sa boxes na ito, yung mga different electromagnetic waves in the electromagnetic spectrum. So, ang clue ninyo would be the wavelength, the size of the wavelength. So, ang may pinaka longest wavelength is what wave? You write it on number 1. Tapos, ang merong shortest wavelength, you write it on number 7. Tapos, dito sa gitna, sa number 4, the electromagnetic wave that can be seen by our eyes is called what? Tapos, the electromagnetic spectrum that can be seen by our eyes is divided into different color spectrums. So, susulat nyo yan dito. Tapos, dito po, what happens to the wavelength here? Longer ba or shorter? Yun ang choice natin. Tapos dito naman sa kabila, longer or shorter. Next, for frequency and energy, ang choices nyo lang po ay lower or higher. Dito rin, ang choices lang natin lower or higher. What I have learned. Letter B, fill in the blanks. So after the discussion of module number 5, characteristics of light, you will now be able to complete this paragraph. So sa mga blank spaces, ilagay nyo yung mga tamang terms na dapat ay nakalagay dyan para makompleto natin yung thought ng ating paragraph. Next, what I can do. Directions. Record your interactions with electromagnetic waves for 1 day. So, the title of this activity is My Electromagnetic Diary. So, first column, time. Second column, activity. Third column, type of electromagnetic wave. And last column ay source. So, for example, at 5:30 a.m., you switch on the lights at home. So, the type of electromagnetic wave that you encountered is visible light. At ang source nito ay light bulbs. So, sa mga susunod na mga rows, ilalagay ninyo kung paano kayo nagkaroon ng interaction with electromagnetic waves. Next, assessment. Answer the question on pages 23 to 24 of Quarter 3, Module 5. Additional activity, performance task number 3.5, explain the uses of light in each category. So here in this empty column, you are going to write your explanation kung paano ginagamit ang light sa bawat figure na ito. So first, we have eyes. Next, a plant. Number 3, sun. 4, satellites. And number 5 ay solar panels. So for Science 7, Quarter 3, Module 5, Characteristics of Light, here are the things that you need to have on your answer sheet. So number 1, what I know. Number 2, what's more. Answer independent activities 1, 2, 3, and independent assessments 1, 2, 3. What I have learned, what I can do, assessment, and additional activities. So the additional activities will be your performance task number 3.5. So if you're done with your answer sheet, you may upload them in PDF format in your Google Drive folder, ang pathway natin, Science 7, Quarter 3, Module 5. Or you may send them in JPEG format to my messenger. So thank you for attending our Science 7 online class. God bless you all.